Okay, so these are page 56 in the textbook, and what I've done is I've typed out the examples for you so that you've got a copy of them. So when you go on to study physics, then you've got examples of these in your book, in your binder, that of course you're going to keep, right? You wouldn't dare think about throwing away your physics notes, right, Ben? No, that would be foolish. Okay, so these are example questions on page 56, and there's a warning that they get challenging real soon. These are the formulas that you need. Here we go. Example number 7 then. Kitty O'Neill, a female dragster, reached a speed of 628 kilometers an hour from rest in 3.72 seconds. How far did she travel in that time? How far did she travel in that time? Pardon me? I don't think so, no. Isn't that with isn't that E-I-L? I think so. Is it? I don't know. Okay, so what do you think the first step should be? Change it to meters per second, exactly. So we're going to take 628, and we're going to divide by 3.6, and I get 174.4 meters per second. And that all occurs in a time of 3.72 seconds, right? We're solving for distance, and this here is my final velocity, right? VF, because she started from rest, and she's reaching 174.4 meters per second. How far did she travel in that time? How can I do this? Is there one thing I need? Do I have a formula with VF, T, and D in it? Do I have a formula with VF, T, and D? Like this one, almost all of them are going to require that I have what? Acceleration. Now I happen to just look at this formula sheet right here, and do you guys have it changed? Yeah, you do, right? This should not be V bar here, it should be delta V, right? Do you guys have yours changed on yours? All right. So the first thing we're going to have to do here is take the acceleration, delta V over delta T. Change in velocity is going to be 174.4 minus 0. Do you really need to show that? Probably not anymore. Over a time of 3.72 gives us an acceleration of 7.77 meters per second squared. So every second, her speed is increasing by 7.77 meters per second squared. That doesn't seem quite right. I'm looking at the wrong value here, aren't I? What should it be? 46.9. Yeah, that's way more. I was looking at the next. I was looking at example 8. 46.9. 4 by 4. Right here. Delta V, change in velocity. Okay, and then your next step would be VF squared equals VI squared plus 2AD. I'm having a hard time with my hand today. Okay, so VF squared is going to be 174.4 squared. The initial velocity is going to be 0. Acceleration 46.9, and we're going to solve for D, which means that D is going to be 174.4 squared all over 2 times 46.9. Now on your calculator, you might have to be careful with that, because you have to make sure you divide by 2 times 46.9, right? So on your calculator, you would have to actually go 174.4 squared divided by bracket 2 times 46.9 end bracket, and then equals is 324.3. You might want to just try that on the calculator to make sure you can do that. Number 8 says, a Ferrari moving at 20 kilometers an hour accelerates at 230 kilometers an hour in 7.5 seconds. As it does so, it covers an unknown distance. Find the distance covered. So similar type of thing. Just going to make it a little smaller, I think. Okay, so the first step is, again, you're going to have to convert those, right? The initial velocity of 20. Divide that by 3.6. You get 5.6. Do the same thing with the final velocity. (230) divided by 3.6 gives you 63.9. I think I need to do this maybe. I'll just write a little bigger.
Is that 63.9?
Yeah. Basically, this is exactly the same question. The only difference is you're not starting at 0. That's right, Levi. Go ahead.
It doesn't state like how many decimals.
Go one more than what's given. Like this is no decimal places, so I would go to 1 decimal place. Just sort of a general rule I use.
That one be times instead of 5?
No, you're going to meters per second, so you're making smaller, dividing. So this is going to be 63.9 minus 5.6 all over 7.5, which gives us, here's where that 7.77 comes in. Okay, now you can go to the formula. Vf squared equals Vi squared plus 2AD. Here's where your math skills come into play. 63.9 squared, 5.6 squared plus 2 times 7.77 D. And you'd have to rearrange that. Can you do that in your head? Like not the math, but can you do the rearranging part in your head? You have to subtract the 5.6 squared, right? It would be 63.9 squared. This is, the 5.6 squared is attached by adding, so we have to subtract it. And then divide by 2 times 7.77. And again, the use of brackets on your calculator will come in very handy. If you don't know how to use them, it's time to learn. Okay, so you would go bracket, maybe I'll wait. Okay, so to do that on your calculator, you would go left bracket, 63.9 squared minus 5.6 squared, close bracket, divided by bracket, 2 times 7.77, close bracket, equals, what have you got? 260.8 meters. Better reorient. You say tomato, I say tomato. You guys want to try number 10? Why don't you guys try number 10? Take a couple seconds to try that one. Yeah, there's some conversions here you got to worry about, right? Calculate the acceleration of an airbag if it deploys in 30 milliseconds and moves out a distance of 40 centimeters. Well, the first thing, if your time, oh yeah, I hate that. If your time is 30 milliseconds, you divide by 1,000, so that's going to be 0.030 seconds. Okay, and your displacement, if it's 40 centimeters, that becomes 0.4 meters, right? I can understand maybe not being able to knowing the milliseconds, but the centimeters to meters you got to know. Okay, once you got that, D equals VIT plus 1/2 AT squared. We're solving for the acceleration. So the distance is 0.4. The initial velocity would be 0. That's always nice. Plus 1/2. We're solving for a 0.03 squared. Okay, rearrange that. A is going to be equal to, if you're dividing by 2, you have to multiply by 2, right? So it's going to be 2 times 0.4 all over 0.03 squared. And did anyone get 888.9 meters per second squared? Because the A is divided by 2, so to get rid of divide by 2, you could also, because you could say, well, it's times by a half, you could divide by a half. Same thing, right? Dividing by a half or timesing by 2. Okay. Okay, now the last one here on this page, is this one on your page too? No, you got to flip over, right? For Jane Bond. Jane Bond. Pardon me? Or sister, I don't know. They're in the book. I'm just going along with what they got in the book. So, Jane Bond runs down the sidewalk, accelerating uniformly at a rate of 0.2 meters per second squared from her initial velocity of 3 meters per second. How long will it take Jane to travel a distance of 12 meters? How long will it take? So now I'm solving for time. Solving for time. Well, let's see what we've got. We've got an acceleration of 0.2. We have an initial velocity of 3, and we have a displacement of 12. Which one has d, a, vi in it? And t? Well, it would be our new friend d equals vit plus 1/2 at squared. Yes, your new friend that you were supposed to play with this weekend. Distance of 12. Initial velocity of 3t plus 1/2 acceleration 0.2 t squared. Uh-oh. Can I isolate t here? I'm going to have 0 equals, let's see, 1/2 of 0.2 would be 0.1 t squared plus 3t minus 12. And what do? The opposite of the inside-outside thing. How do you solve for t when it's quadratic like that? Like.
Can't you like take the T out somewhere?
There's no t to take out of here.
And just like put that onto that side. And
Well, if you're still, yeah.
then take the T. Just throw it.
Because now I'm going to use the quadratic formula. You got to have one side equal to 0 to use the quadratic formula. Yes. The quadratic formula. Remember, basically, what you've got here now is a quadratic equation, and so what you're saying is, here's your equation, and you're solving for the, what are those called? The zeros or the roots, right? Just a reminder. The zeros are the roots. Okay, and to find the zeros of the roots, you have to have one side set equal to 0. Okay, and that's the basis of the quadratic formula. And the quadratic formula is going to be t equals minus b, right? Plus or minus the square root of b squared minus 4ac all over 2a. Dumb. Which one is b? Just the 3, actually. So that's going to be minus 3 plus or minus square root of 3 squared minus 4 times a is 0.1 and c is minus 12. All over 2 times a, right? 2 times
And where is point one coming from?
A, B, C. You remember the quadratic formula? A, B, C. Now, can you solve that in your calculator? You'll have to. Can you eliminate one of the two? Well, let's just do this. Let's do the 3 squared minus 4 times 0.1 times minus 12, and you should get, after you take the square root, 3.7, I think. Okay? That'd be 3 squared. I'll get my calculator up and running here. Okay, so here's my calculator. So it's going to be 3 squared. So that's 3 times 3 minus 4 times 0.1 times negative 12. I get negative 6. What's going on there? Note this calculator does order of operations. Did you all get 3.7 for the square root value? Okay. And that's all going to be over 2 times 0.1, which of course is 0.2. Now at this point you can say to yourself, well, there are going to be 2 answers, okay? If you work that out, it's going to be minus 3 plus 3.7 is going to be 0.7 all over 0.2, which gives you a t time of 3.5 seconds. That's t time. And if you use the negatives, you're going to have minus 3 minus 3.7 is minus 6.7. Divide that by 0.2. You're going to also have a value of minus 33.5 seconds. Can you have a negative t time? Okay, what's happening here? Well, remember, it's a quadratic, right? Like that. And so the curve says, yeah, there's a 0 over there. Okay? But all the quadratics in physics, we're only dealing with the what? We're only dealing with the positive side of the quadratic. Okay? So this one, yeah, this one just sort of disappears. Okay? And in fact, you don't even need to figure it out as long as you know that it's a negative. There may be some problems where there's 2 possible positive times. And you're going to see one of those very soon. But in this case, the one time is negative, which just means it's sort of a non-thing. Okay? So the answer here is 3.5 seconds. That's how long it will take for her to travel the distance of 12 meters. Okay, you've got a few minutes left here. I'm going to leave examples 12 and 13 because they are rather challenging. So hopefully you've had your shot of coffee tomorrow because you're going to need your brain in full gear tomorrow. I will give you the remainder of the time to continue working. Tomorrow I will be checking to see if you've got those questions done, i.e. homework, the ones on the front, the questions. There's a few on the back too, I think, right? Okay? And you should get a good start on the problems as well. Okay? In 25 minutes, you should be able to get at least 10 or 12 questions / problems done.
Right now?
1 to 18. Yeah, you should be able to get 10 or 12 questions done in the next 25 minutes.